These notes are on 5.3 sublevels and orbitals. The learning goal is to describe the sublevels and orbitals in atoms. This stuff can get a little complex, a little confusing, so put your thinking caps on and try and keep all of the things straight that we're talking about. If you have any questions, definitely let me know. All right, so we're talking about electrons and where electrons are found in an atom. And we talked about Friday that they're found in energy levels, okay? We said those energy levels are assigned numbers, 1, 2, 3, and it goes all the way up, okay? So as those numbers go up, the energy that the electron has goes up. So if you're in n equals 3, you have more energy than if you're at n equals 1. Now, there's an equation that tells us how many electrons can live or be found in each energy level. And the equation is 2n squared. So in energy level 1, you have 2n squared where n is 1. So 2 times 1 squared is 2. So in the first energy level, you have 2 electrons, maximum number of electrons there. Yeah, you can have less than that, but the maximum you can have is 2. Then you've got, in your second energy level, 2 times 2 squared, which is 8. So you can find 8 electrons there, maximum. In your third energy level, you have 2 times 3 squared, so you have 18. And in your fourth, you have 2 times 4 squared, which is 32. So the maximum number of electrons you can have in each energy level goes 2, 8, 18, 32. Now, within each energy level, there are sublevels, okay? So imagine if you were on the second shelf of the bookshelf, there's subshelves in there, okay? And to keep these straight from the energy levels, we give these letters. So we call these S, P, D, and F. The number of sublevels in each level is equal to the energy level you're in, the principal quantum number. So if you're in energy level 1, you can have 1 sublevel, and it's going to be an S sublevel. In your second energy level, you have 2 sublevels. You have S and P. In the third, you've got 3. You've got S, P, D. And in your fourth, you have all 4. You've got S, P, D, and F. These are the sublevels within each energy level, okay? And the way we label them is we label them by the energy level and then the type of sublevel. So if you're in energy level 2 and you're in the P, we call that 2P or 3S or 4P, 4S, okay? So it's the energy level, then the sublevel. Just like when you go up in energy levels, you increase in energy. If you go up in sublevels, you increase in energy. So S has the lowest energy, then P, then D, then F. Okay, so a quick learning check. Identify the sublevels in each of the following energy levels. So if you're in n equals 1, what sublevel do you have? Well, you've only got 1. You've got S. And what do we call it? We call it 1S. So for A, you've got 1S. All right. So for B in n equals 4, what sublevels do you have there? Well, you think back, the number, your energy level you're in tells you how many sublevels. So in n equals 4, I have 4 sublevels. I've got 4S, 4P, 4D, and 4F. Okay? So for n equals 2, I'm going to have 2 sublevels, and it's going to be 2S and 2P. Okay? You want to remember S, P, D, F. That's the order they go in. All right. So those are the answers. Let's talk about orbitals. So now you've got energy levels. Okay? You can imagine you've got your S, P, your D, or your 1, 2, 3, 4. You've got your sublevels, S, P, D, F. Orbitals are just the shape. Okay? So an orbital is the 3-dimensional space around a nucleus where an electron has the highest probability of being found. We're throwing out the idea of planets moving around the sun, orbits, okay? It's not like that. It's just an area, it's a volume where you could find an electron. And so the shape represents the its electron density, which is like where might it be found. So it's not a path the electron's following. It's just an area where it might be found. So let's talk about the 4 orbital shapes, because at S, P, D, and F all have their own different shapes. So S has this most simple one. stands for spherical. So in an s orbital, electrons are found in a spherical shape. So here's your 1s orbital, your 2s orbital, your 3s orbital. Okay, so this is where the electrons are most likely to be found. As you go up into higher energy levels, your s orbitals get bigger. So 2s is smaller than 3s. So s is a spherical shape, and as we get into higher energy levels with an s, you get bigger spheres. P, so s had one orbital, it's just a sphere. P has 3 orbitals, okay? And they kind of look like dumbbells or like a balloon pinched in the middle. And so there's 3 of those, so this is each of them separately. And then when they're all together, they look kind of like this funny looking flower over here, okay? So you have 2p, 2p, 2p. This is all of the p's put together. So you've got your 3p orbitals put together. They're arranged perpendicular to each other, so you've got one on the x-axis, one on the y-axis, and since we're talking in 3 dimensions, we've got one in the z-axis, which you might not have heard of before, but you can think of it as like length, width, and height. And when I draw these, I just draw them kind of like infinity signs. So I draw, there's one, okay? There's another one. And then I just draw one kind of across to represent the last one. So those are my 3p orbitals. They're shaped like that. Okay, so when I get to energy level 2, well, energy level 1 is really boring. It just has one s, it's one sphere. When you get to energy level 2, you've got 2 sublevels. You have your s and your p. 2s, 2p. 2s has 1 sublevel. Okay, so if you look down here, 2s sublevel has a 2s orbital that's shaped like a sphere. Okay, in your 2p sublevel, you have 3 orbitals, and they're shaped like these weird little dumbbells, balloons, whatever you want to call them. All right, so in your second energy level, you have 2 sublevels. You have 2s and 2p, and those sublevels have different orbitals. 2s has a spherical orbital, 2p has the p-shaped orbital. So now we're moving into energy level 3. Okay, energy level 3 has 3 sublevels, s, p, d. 3s, 3p, 3d. 3s has just a sphere, because all the s's are always spheres. 3p has those 3p orbitals. 3d has 5 orbitals. You will not be responsible for knowing the shape of the 5d orbital, but just know that there's 5 of them, okay? So if I were to make a little chart for myself, I would know that S has 1 orbital, it's a sphere. P has 3 orbitals, and they're shaped like our special flower here. D has 5 orbitals. Oops. I'm going to show you the shape of those, but you're not going to have to know those. So here's the shape. This is 1, 2, 3, 4, 5. Put them all on top of each other, and that's what the d orbital looks like. It's craziness. We get to energy level 4, you have the same thing. You've got 4s, 4p, 4d, and then we add 4f. So 4s has a sphere, 4p has the 3p orbitals, 4d has the 5d orbitals, and for f, it has 7 orbitals. So f has 7 orbitals, and they're even more complex than the d ones, so we're not even going to look at those. Okay? All right, let's take a look at some questions. Indicate the type and number of orbitals in each of the following energy levels or sublevels. Okay, so in the 4D sublevel, 4D, well, D has 5 orbitals, right? So you have 5D orbitals would be the right answer for that one. Okay. 4D orbitals, technically. In n equals 4, well, n equals 4 is an energy level. So we're going to have 4s, 4p, 4d, and 4f. So we're going to have one that's a 4s orbital, right? It's going to be that sphere. We're going to have 3 4p orbitals, those 3 p's. We're going to have 5 4d orbitals. because D has 5 orbitals, and we're going to have 7 for F orbitals. So we're going to have all these orbitals. And lastly, in the 2p sublevel, well, in P, how many do you always have? 3 p orbitals, right? So you're going to have 3 p orbitals. They're going to be the specific 2p orbitals, okay? We have 3 different ones. This chart might help you if you wanted to copy that down. It shows you the energy level, the number of sublevels in that energy level, and then the different types and numbers. So in energy level 1, you have 1s, and there's only 1 orbital. So it shows you all those. So that's a good chart to copy down. All right, one more thing we got to cover in this section: orbital capacity and spin. So there's this principle called the Pauli exclusion principle, and it says that each orbital can hold a maximum of 2 electrons. Very, very, very important. Each orbital can hold a maximum of 2 electrons. Very important. Now, the other thing Pauli said is the reason why it can only hold 2 electrons is because an electron is seen as spinning on its axis. It has this property called spin. And when an electron spins, it makes a magnetic field. Well, that magnetic field is going to interact with other magnetic fields from other electrons. And so what they do is they say they must spin opposite directions. So if they're in the same orbital, they can have different spins. And we call it spin up and spin down. And so you can think about it as like clockwise and counterclockwise. Well, they just give it a spin up and a spin down. Kind of confusing to wrap your head around, but think about it if it were spinning and you were like wrapping your head around it, your thumb would point up. If you wrap your hand the other way around it, it would spin down. And so that's how they say spinning up, spinning down. So 2 electrons per orbital. The reason why there's only 2 electrons per orbital is because their magnetic fields need to cancel out because they have to have opposite spins. We represent the opposite spins with up and down arrows. So an S orbital, an S sublevel only has 1 orbital, and it can hold 1 electron or it can hold 2 electrons. Because each p orbital, remember there's 3 of them, each one can hold 2 electrons, that means total I can have 6 electrons in my p orbital. In a d sublevel, there's those 5 d orbitals. Each one can hold 2. So that's 2, 4, 6, 8, 10. D can hold 10 electrons. F has 7 orbitals. It can hold 14. Okay? So we can make a little chart with this just to wrap our heads around it. S can hold 2 electrons in 1 orbital. P can hold 6 electrons in 3 orbitals. D can hold 10 electrons in 5 orbitals. And F can hold 14 electrons in 7 orbitals. Okay? Now if we think about this, energy level 1 just has S. That's why energy level 1 can only hold 2 electrons. Energy level 2 has S and P. That's why it can hold a total of 8 electrons. See, the math's adding up. Energy level 3 has S, P, D orbitals. So it can hold 18 electrons. That's the same thing we wrote down in the beginning. And energy level 4 has all. It can hold 32 electrons. So that's where we get those numbers from. All right. Number of electrons that can occupy a p orbital. P can hold how many electrons? Each one can only hold 2. Okay, the answer is 2. Each orbital can only hold 2 electrons. P orbitals in the 2p sublevel is how many orbitals? There's 3 p orbitals every time. And then last one, d orbitals in the n equals 4 energy level. How many d orbitals are there? There's always 5 d orbitals, so that one's 3. Awesome. Draw a line into those notes and you are done.